Before you watch this video, make sure you have both handouts. So make sure that you have the directions. That's the handout that says at the top, the advantage of blocking. You want to make sure that you have this handout. On the front page at the top, it says Method 1, the simple random sample. So these are the templates you're going to complete. You'll also need your calculator. And then you should also get a coin. I left a bag of pennies, so you can grab a penny. Make sure you have all of these supplies. We are not going to do it together. What I want to do is show you the basic way that the instructions are laid out so you'll be successful completing this simulation. So again, make sure you have all of these supplies. If that hasn't happened yet, then please pause the video and then replay the video once you have all your supplies. So here's the idea in this simulation. I've asked you to try this question already. So the question is, which of the blocking schemes was better for these dwarf fruit trees, blocking scheme A or B? Well, we're actually going to simulate assigning the trees to plots. And we are going to do this three ways. A design that uses no blocking, so just using a simple random sample. We'll simulate blocking scheme A and blocking scheme B, and then we'll look at all of the data that you're generating. We'll do that later. And we'll actually be able to see pretty clearly which method helps you uncover the truth. So that's why this is important. We're assuming that the new variety really is better. So let's say the new variety has an average production of 53 pounds of fruit. The old variety produces only 47 pounds of fruit. So if you look at that, the true difference is 6 pounds of fruit. So our job is to decide which of these methods, the SRS, blocking scheme A or blocking scheme B, which is the one that will help us most easily uncover that true difference of 6. So we're also going to assume that trees that are closer to the forest grow more poorly than those that are farther away. So we'll say that the forest consumes or pulls nutrients and water, etc., from the land. So trees that are next to the forest will have their production automatically decreased by 10 pounds. That's the effect of the forest. Trees that are planted away from the forest will have their production increased by 10 pounds. So you'll see on the template, all of the boxes that are next to the forest, those all have a -10 in them. All of the plots that are farther from the forest have a +10 in them. That's the effect of the forest. So, also, even within a variety of trees, there's natural variability in productivity from tree to tree, and also the individual plots in the field will have differences due to water, fertility, etc. So in this simulation, the variability of the trees and the plots will also account for that by adding or subtracting a random quantity for each tree. So to be successful doing this simulation, what you have to do is read the directions. I would advise you to read the directions, and as you complete each step, cross it off. So first of all, your first job is to execute the command random integer 181. So this means we are choosing one random integer between 1 and 8. So on your graphing calculator, to get to that command, turn it on. To get to that command, press the math button. Press the right arrow 3 times to go to the probability menu. Press the down arrow and you'll get the random integer command. Press enter. Now, I don't have a menu. If you have a menu, I believe it should say lower, upper, and number. So the lowest random integer I want to generate is a 1. So on this type of calculator, I have to put a comma next. The highest type of random integer, the highest integer I want to randomly generate is 8. 1 to 8, I'm generating a plot randomly. I need another comma, and I only want to generate one number at a time. There's my 1. I'm going to close the parentheses and press enter. So I randomly generated plot number 8. So according to the directions, go to the plot whose number appears, I got an 8, circle new, and put 53 in as the productivity. Now I don't want you to do this with me. I'm trying to show you what you'll be doing and why you can be successful if you just read the directions really carefully. So on my template for the simple random sample, I'm going to go to plot number 8. It gets the new tree variety. its productivity is 53. I circled new, I wrote in 53 because it's a new tree. So now I'm going to execute the above command again. Now, something clever. To execute the command again, you don't have to type it, you can just press enter. Well, look at that. Execute the command again. If the same number appears, ignore it and execute it again. When you get a new number, go to that plot, circle new, and put in 53 again. So I better do it again. There you go, I got a 2. So I'm going to go to plot number 2. I'm going to circle new. I'm going to put in my productivity of 53, and I'll keep going. So, step number 3, you're going to repeat this process until 4 new trees have been planted, and that means then that the remaining plots are all old trees, so circle old and put a 47 in as their productivity. So once you've assigned new trees to 4 plots, you'll go and circle old for the other plots and put in their productivity as 47. Again, I've been really specific with the directions. Okay, now the next thing you're going to do in step 4 is flip a coin. So, and then you'll execute the command 161, random integer. So I'm going to pull that command up, math, probability, random int 1, 6, 1. I'm going to randomly generate an integer from 1 to 6. Okay, so first of all, I'm going to flip a coin. So here I'll flip my penny. Fine, I got a heads. Execute this command. I got a 4. If heads, add the amount indicated by the command as the variation for the tree in plot number 1. So I got a heads, so I'm going to add the 4. So in plot number 1, it would either have a new tree or an old tree. The productivity would already be labeled. The variation is 4. So this tree, for whatever reason, is extra productive. So if it's tails, you're going to subtract the amount indicated by the command as that variation, and you need to do this for all 8 plots. So again, I'll flip my coin. Let's say the coin comes up tails. Fine. I'm going to execute this same command, 1, 6, 1. This time I got a 3. So tails means I'm going to subtract, and I'm going to subtract the 3. So for plot number 2, for whatever reason, this plot or this tree is less productive, I'm subtracting 3. You're going to do this for all of the plots, all 8 of them. Cross it off, turn the page. Again, I don't want you to do it with me right now. I just want to make sure you understand the process. So step 5, you're going to find the total productivity for all of the plots. So you'll total them up. Combine these 3 numbers, find your total. You'll do that for all 8 plots. Cross it off. Step 6, you're going to list the total productivity for the 4 new varieties. Find their average to 2 decimal places, please. 2 decimal places. If you've done it correctly, the likelihood is it'll be between 35 and 65. So find all of the new trees, like this one. Find their total productivities. You want to go down here and list them all. So list all of the total productivities for the new trees. Find their average. Similarly then, in the next step, you're going to list the total productivity for the old trees. Find their average to 2 decimal places. So everywhere where you've circled an old, take those totals, put them down here at the bottom where it says old total productivity. You'll have 4 trees. Find their average. So then you want to find the difference between new and old, and then finally circle the variety that had the higher average productivity. So you want to find the difference between these 2 averages at the bottom. So this is new, this is old. You'll take the top one minus the bottom one. You'll find that difference here, and then you'll want to circle which variety had the higher productivity, the new or the old. So if this is positive, the new trees had the higher productivity. If it's negative, the older trees had the higher productivity in your simple random sample. But that's just the simple random sample method. Now you have to follow the directions carefully enough to continue with method 2 to simulate blocking scheme A, or to continue with method 3 to simulate blocking scheme B. So again, I didn't want you to do it with me. I want yours to be different from mine. I'm just trying to show you how carefully I've written the directions. If you follow the directions really carefully, you'll be in great shape. These are the directions for method 2. That's for simulating blocking scheme A. There are the first 9 steps there. It continues on this side. There's a total of 12 steps. And then to simulate blocking scheme B, this is method 3. This will be the last page of your template. So again, there are 12 steps to do that. Follow them carefully, read them carefully, cross them off, help each other if you're confused. Okay? So once you are done then, this is important, make sure that your template, which should be stapled together, make sure you put your name on it and turn it in. Put your name on it and make sure you give it to the teacher, because I'm going to go through and look at your data. I'm going to give you credit for having done the simulation, and I want you to go through. I'd rather have to go through and look at the data so that I can combine it and we can present it and we can actually see which method is more productive. In other words, when I say more productive, which method helps get us closer to the true difference of 6 pounds more easily.